Hello viewers, in today's class we are going to discuss a very important and conceptual problem from limits involving the greatest integer function and the absolute value function, right? So here we have an important problem and we have to evaluate this limit, that is limit x tends to 0 minus. So here the negative sign shows that we have to find the left hand limit of this function when x approaches to 0 from the left of x is equal to 0, right? So basically we have to find the left hand limit of this function when x approaches to 0, right? And here we have the function that is x multiplied with the greatest integer of x plus the mod of x, and then we have sine of greatest integer of x and divided by the absolute value of x, right? So let us see how we can evaluate this limit. So to evaluate these type of limits, what we do, we'll take x is equal to 0 minus h, right? So here we have x tends to 0 minus, so we'll introduce a quantity h. It means we are in the neighborhood of x is equal to 0 or in the left neighborhood of x is equal to 0. So we are here, that is 0 minus h, right? So whenever we have x tends to a minus in general, then we take x is equal to a minus h, right? Okay, and when x tends to a, then obviously h tends to 0, and here h is a positive quantity, and h lies between 0 and 1, right? And when x tends to 0, then h tends to 0, right? So we'll take x is equal to 0 minus h, right? So this is simply minus h. So now this limit which we are calling left hand limit is the limit, and now we'll transform this limit in terms of h. So we have h tends to 0, and for this x we can now write minus of h, and then we have greatest integer of minus h because we are replacing x by minus h, right? And then we have mod of minus h, and then we have sine of greatest integer of minus h divided by the mod of minus h, right? So now see, here we have greatest integer of minus h, right? And here also we have greatest integer of minus h, and these two are mod of minus h, and here we are simply having minus h, right? So now see, h it lies between 0 and 1, right? So h lies between, so h lies between 0 and 1, right? So if we multiply this inequality by minus 1, then we have 0 greater than minus h greater than minus 1, right? So when we multiply this inequality by negative 1, then the direction of the inequality get reversed. So we can now write this inequality as minus 1, then we have minus h, then we have 0, right? So this inequality suggests that minus h, it lies between minus 1 and 0, right? This is minus 1 and this is 0. So minus h, it lies somewhere between minus 1 and 0. So by definition of greatest integer function, the greatest integer of minus h must be equal to minus 1, right? So here this quantity must be replaced by minus 1, and here also we have minus 1, right? So now we can write limit h tends to 0. Here we have simply minus h, and then here we have minus 1, and here we have mod of minus h, and here we have sine of minus 1, right? And divided by mod of minus h, right? So now viewers, now we have to take care of this mod of minus h, right? So mod of minus h is equal to a positive h, right? By definition of absolute value function, right? So now this limit can be written as limit h tends to 0. Here we have minus h, then we have minus 1, then mod of minus h is simply h, and then sine of minus 1 can be written as minus of sine of 1, right? Because from trigonometry we know that sine of minus theta is equal to minus sine theta, right? And here in the denominator we have simply h, because mod of minus h is equal to h, right? So now we can simplify this expression. Now this h and this h get cancelled, and here we have minus sign, here also we have minus sign. So these two minus sign get multiplied and will get a positive sign, right? So now we have limit h tends to 0, and here we have minus 1 plus h, and minus becomes plus, so we have here simply sine of 1, right? So now we take h is equal to 0 here, so we have minus 1 plus 0, and here we have sine of 1. So now minus 1 plus 0 is minus 1, so we have minus sine of 1, right? So the value of this limit is equal to negative of sine of 1, right? So viewers, this is how we can solve these type of limits.